Okay, the next test, this exercise 13.2C, this includes B9, 10, 11, okay. Page 233, so B9, let us go and read. Listen carefully, if number 1. So let us do the number 1. Find the lateral or curved surface, because lateral or curved surface of a cylinder is same, of a closed cylindrical petrol storage tank that is 4.2 meter in diameter and 4.5 meter height. So there is a cylindrical tank closed at the top. Keep that in mind, this closed. Diameter is 4.2, means from here to here is 4.2 meter. The height means from here to here is 4.5 meter. So a big tank, petrol tank, storage tank. So here 4D petrol storage tank, which is cylindrical obviously. The R radius is diameter divided by 2 meter. 2 ones are 2, 2 twos are 4, 2 ones are 2, so 2.1 meter is the radius of the storage tank. Hope that's clear, right? And the height of the storage tank is 4.5 meter, its height. Right. Question is saying find the lateral or curved surface here. So you write here. Therefore, lateral or curved surface area of this storage tank, cylinder curved surface is formula 2 pi RH, right? Simple as that. So that will be 2 into 22 by 7 into R, pi 22 by 7, R is 2.1 into H is 4.5, and area means we can just put meter square at the back. 7 ones are 7, and here as we cancel, we have to take only one digit at a time. 2 is lesser than the divisor 7, so we put 0 first. Then only 21 will combine with 1 and 21. And 7 threes are 21. So our job next is to do this. Okay, let's do this. 45 into 2, forget the decimal, it's 90. 45, 245 means 45, 45. 45 plus 45. 90. So one decimal means point. So when we multiply these two, we get 9.0, means simply 9 we're getting. The 9 threes are, these two, 9. 9 threes are 27. So this disappears. One decimal place means from here we go, so 2.7. So these two multiply 9, and then multiply 9 to this, 2.7, and multiply to 22. Is our answer for lateral surface. 2 sevens are 14. 2 twos are 4 plus 1 remainder 5. So 4 and 5. 4, 9 and 5. One decimal place means move here. So 59.4. So we get here 59.4 meters square. That's the lateral surface area. First answer. Second part, okay, so this is number 1, you write. And number 2. Number 2 is how much steel was actually used if 1 by 12 of the steel actually used was wasted. So let us say let X be the, okay, X be the steel actually used in making the tank. It means that is including wastage. So this includes not only the exact tank but including wastage, because in making a tank some part will be invariably wasted, right? So that wastage is also included in the X. So therefore the wastage, looking to your question, is equal to 1 by 12 of the steel actually used. 1 by 12. 1 by 12 of steel actually used. So common sense tells us this one. 1 by 12 of means into. Steel actually used is here. X, including wastage. So 1 by 12 X is wastage. That is, okay, steel used in exact steel used. If you want to put area, steel area used in making the tank. What we mean here is without wastage, exactly fitting the tank and no wastage included. That's what exact steel area used in making this tank, that is without wastage. This, by our common sense, also we know that it will be equal to its total surface area or surface area, right? So as we keep on doing, that implies now the steel used total including wastage is X minus wastage here, 1 by 12 will be the exact steel used without wastage. Total minus wastage is the exact steel used in fitting the tank. So exact steel here is X minus 1 by 12, the left side, this one. And its total surface area formula is 2 pi r into H plus R. Right. This part is completed, so let us just wrap it out and continue. So next here, that implies 12 into x is 12x minus 1x is 11x. So 11 by 12x. 12 ones are 12x minus 1x, 11x by 12. Or 11 by 12x, same thing. 2 into 22 by 7 into 22 by 2 pi r. R is here 2.1 into h plus r. So h is here 4.5 plus r is 2.1. We can just write the big ones, meter square. So that will imply 11 by 12x. We'll solve this part a little bit. 7 ones are 7. 2 is less than 7, so 0 point. Then it becomes 21. 7 3s are 21. 2 into 44. 2 into 2, 44. 44 into 0.3. You see here is 3 4s are 12. 3 4s are 12, 13. So when we multiply 2 into 22, 44, and multiply the 0.3 up to here. One decimal place because on the right one, so decimal move here between 3 and 2. This part multiplied gives us 13.2 into 4.5. Okay, 4.5 plus 2.1. Both are plus means we add, so 6 here and 6 here. 6.6. And here meter square, these two added 6.6 meter square, right? Then here, as we continue, we will get here, that implies x will be equal to, this part we can just write it, 13.2 into 6.6 meter square on the numerator, same thing. When you shift 11 by 12 to the right side, denominator 12 will go up. So let's write here 12, and then numerator 11 will come down. So that's the x value, exact steel use including wastage. The question is asking this. So 11 ones are 11. Okay, then 11, okay, ones are 11 point, then 12, 13, 2 remain there. So we'll go to the next two and combine 22. 11 2s are 22. Now we know from our memory also 12 into 12 is, without considering decimal, 144. One decimal means here decimal will come. to the left, because one decimal place on the right of point is decimal. So this is done, multiplied it to 6.6. Right. 6 4s are 24, 2 in hand. 6 4s are 24 plus 2, 26, 2 in hand. 6 1s are 6 plus 2 remainder, 8. So 4, 6, 8 again, because the same number repeated. So 4 on addition, 10, 1 remainder, 8 plus 6, 14, plus 1 remainder, 5, 15, 1 remainder again, 8 plus 1 remainder, 9. Decimal place means on the right of points, 1 here and 1 here, so 1 plus 1, 2. 1, 2 starting from extreme right, so it will become in between 5 and 0. So the actual total amount of steel used, including wastage, is 9.04 meter square, our answer. Right, because the question is asking how much steel was actually used, means including the wastage. So we can just stop there, then 9. Next we go to 10. Okay, 10. B10. We read the question for us. In the figure 12.13, so the textbook figure looks like this. There's a cylindrical frame having iron bars like this. 1, 2, 3. So figure 13.12. We see a frame of lampshade which is cylindrical shape. It is to be covered with decorative cloth. The frame has a base diameter of 20 centimeter. So figure 13.12. So here in figure 13.12, according to question, radius of the frame, cylindrical frame, will be the diameter, means from here to here. The question is saying 20 centimeter. And the height is 30 centimeter. This only frame, cylindrical shape. So the radius is diameter divided by 2 centimeter. 2 1s are 2, 2 10s are 20, so 10 centimeter is the radius of the frame. Then the height of the frame is 30 centimeter, its height. Okay, so this is figure 13.2. So they're going to put a decorative cloth. A margin of 2.5 centimeter is to be given for folding it over the top and the bottom also. So since a margin of 2.5 centimeter is to be given when we put the cloth, to be given for the purpose of folding. Okay, folding it over the top as well as the bottom and bottom. Because of this, therefore, in figure 1, let us say, let's draw the figure in figure 1. So the steel frame is like this. Actual steel frame provided by the question itself is 1, 2, 3 steel frames. We're going to put a cloth now. So the cloth is going to have like this structure. So this is the frame, then extra margin is to be put. So this is actually before the cloth come in, 30, we know that. And this portion will not change, the radius from here to here, or diameter from here to here. 20, these things will not change. This is figure 1. But when they put the cloth, this is up to here is the steel frame. 1, 2, 3 here. 1, 2, 3, 4. Okay, 1, 2, 3, 4 up to here. So this we know 20 and this height. the extra cloth margin to fold it over there. Iron rods, rods. And here extra folding at the bottom also, top also. And bottom also extra folding of 2.5 centimeter extra cloth is to be provided. So this is the picture before folding, okay? Before folding. Now, they're saying if this is the case, then how much cloth will be required? So, for figure 1, R will remain same. Even though you put extra cloth, the radius won't change. So that is, R is already here, 10 centimeter calculated. What will change is the height. Is the radius in the new figure also. Then H will change. H will be the all height here from here to here 30 is put as H, small h, plus extra margin of 2.5 at the top, so we write 2.5 centimeter, plus in the bottom also 2.5, top and bottom, as you can see here, top and bottom. So that will become the new height when the cloth is not yet folded. Okay, so that is H is 30 centimeter plus 2.5 plus 2.5 is 5 centimeter, as you can see, 2.5 plus 2.5. Then 5 plus 5, 10, 1 remainder, 2 plus 2, 4 plus 1, 5. So 5 coming here, so that is 35 centimeter. So they're saying how much cloth is required. So you write here, therefore cloth area required. The question is asking us this one. Cloth area required will be, so this is figure 1 for our on making. Curved surface area of figure 1. So curved surface area of the figure 1 is 2 pi, R is same as you can see, but H is the long one here, capital H. So this is the total area of cloth required. So that will be equal to 2 into pi is 22 by 7 into R is 10, capital H as you can see is 35, and area means centimeter square. As you can see, R is 10, so we put here 10. 7 ones are 7, 7 5s are 35. To make our multiplication easy, multiply these two first is easy. 5 2s are 10 means 1 0. Combine to this 10 become 100, 122, 2 0 centimeter square. That is the answer for total cloth area required, right? I hope you got it, right? One more last question before we complete this test portion. 11, B11. So let's go and do that. B11. The students of a Vidyalaya, means school only, to asked to participate in competition for making and decorating pen holders of the cylindrical shape of a cylinder with a base. So pen holder means the top should be open. Otherwise, how would we put a pen inside? But the question clearly says the base should be closed. This is closed because it has to hold the pen. Bottom is closed. Base is closed. Base is there means the bottom part is closed. Using cardboard material, sorry. Each pen holder was to be of radius 3. So radius means from here to here 3 centimeter. And the height of the pen holder should be 10.5 centimeter. The question did not tell us the pen holder is open, but by our common sense also we know pen holder should be open. That's why we're just figuring that out by our own common sense. Now next, so here for each such pen holder, the dimensions. Small r, let us say radius, 3 centimeter is the radius, right? H, let us say small h, 10.5 centimeter is the height of the pen holder, cylindrical pen holder. Okay, the idea was to supply the competitors with this cardboard material to make the pen holders. If there are 35 competitors, how much cardboard are required? So you write here, since you can just write like this if you want. Now by our common sense also, cardboard area required for each means one each pen holder will be equal to, you see, this is the pen holder, exactly the pen holder that I'm holding. This one should be there, so curved surface area plus the base should be there, so base area or bottom area. But the top area we should not put because it should be open to hold to insert the pen. Bottom should be closed, base should be there to hold the pen. So the formula for curved surface area, 2 pi r h. Base area is, as you can see, the bottom is circular, so area of circle, pi r square. The next that will give you 2 pi r common take out. Sorry, pi r, not 2 pi r, pi r, pi r, pi r, pi r. Then 2h will be inside the bracket plus pi r outside, so one more r because it's r square, pi r into r square. So we can take out the common factor to make our calculation slightly easier. And 22 by 7 into r. So you can see 3 twice into h, here 10.5 plus small r here again 3, close the bracket, and area means centimeter square. This is the area for required cardboard area for making one pen holder. It will be 22 by 7 into 3 into 2 into 10.5 into 2, 2 5s are 10, 0 is there, so 10 I put it, 2 1s are 2. 1 decimal place, so the decimal will come in between 1 and 0, so that is 21. When we multiply these two, plus 3 centimeter square, so there will be 22 by 7 into 3 into 21 plus 3, 24 centimeter square. So this is the cardboard area for each pen holder. But since there are 35 students or competitors, therefore total cardboard area required will be 35 multiplied to, you can write it here, okay, so let me write it once more. Therefore, because there are 35 competitors, total cardboard area required. Total cardboard area required will be number of competitors, 35 multiplied to cardboard area for each pen holder, that is 22 by 7 into 3 into 24 here centimeter square. This is centimeter square, okay, centimeter square. So 7 1s are 7, 7 5s are 35. Then here 5 2s are 10, 5 2s are 10 plus 1 11. So when you multiply these two, 110. Then here, let's just multiply these two. 3 4s are 12, 3 2s are 6 plus 1 remainder, 7. So when we multiply these two, we get 72. When we multiply these two, we get 110. Let's push the 0 a little bit to the side, because we don't need to multiply the 0. So let me just write it, just 72, 110, multiply the 1 2s are 2, 1 7s are 7. Then here 2 and 7, 2, 9 and 7. Finally we can put the 0. So the total cardboard area required is 7920 centimeters square for 35 competitors. So that concludes the part for test 13.2C. Okay, I hope you understood.